You could probably get most of this information from the PowerPoint, but I thought I would make a little video to explain to you with some examples. You're going to be starting Unit 6, which is all about Newton's 3 laws. Everything up until now, what we've talked about is how things move and they accelerate and how their displacement changes. This unit is where we start talking about why. Why is there an acceleration? Why does the displacement do this? Why does it go in the path that it does? The why, not necessarily the how. So this brings us to Newton and forces. Isaac Newton came up with his 3 laws of motion. The 3 laws of motion deal with forces. They are called the law of inertia, the law of acceleration, and the law of interaction. And I'm sure you've heard of them before, probably in middle school. We just go into a little bit more detail about it. So the law of inertia. Inertia is the resistance to motion. It has to do with mass. Newton didn't do a very good job explaining what mass is. He said it was just the amount of matter something had. If you took chemistry, you remember that definition of me maybe saying that it was not a great definition. He defines it a little bit better when he's in a physics realm. So the first thing, the law of interaction says, or the law of inertia says that an object in motion wants to stay in motion and an object at rest wants to stay at rest unless acted upon by an outside force. This might be a little bit confusing. So, or it might seem like it's common sense, neither of which is true. Until Newton's time, very, very close to Newton's time, people thought that there was a property of a substance that kept it moving. I forget what they called it, but there was a property, and then once that ran out, it quit moving. That's not how it works. An object wants to maintain its state of motion. So I don't know how well you can see it, but I have a beaker with a note card and a penny on top of it. And it'll stay there forever until the note card decomposes and then the penny will fall down. But for right now, the note card is holding up the penny and the penny wants to stay there. And it will stay there until I take the note card away. But then if I take the note card away well and just flick it out of the way, the penny's weight will just bring it straight down, and weight is a force. And this is what Newton said. The overall force acting on the penny once the card goes away. Nope. It worked 3 times before I did this. Okay, one more time. It goes straight down. It goes straight down into the cup. I don't know how well you can see that, but anyway, that's an example of the law of inertia. You know this when you drive your car. When you drive your car and you're going in a turn, and if you're going to make a turn, your butt is attached to the car, and so it goes with the car in the curve. Your shoulders aren't. Your shoulders appear to hit if we were making a right-hand turn off of the interstate, your shoulders would move to the left. They're not really. They want to stay in the line of motion that they had. This is the reason we have to have seat belts. If you didn't have a seat belt, you want to stay at 55 miles an hour on the highway. All of a sudden, if you come to a stop and you don't have your seat belt on, you're going to maintain your state of motion and go through the windshield. That's basically the law of inertia in a nutshell. Also, the larger the object, the more inertia it has, and you know that. You know that because it's not easy, but it's easier to throw a baseball than it is a bowling ball. Bowling balls are large. To get it to change its motion, it takes a lot more force. The second law is the law of acceleration, which says that larger forces are needed for bigger masses to make them accelerate. It's basically in one equation that says that the overall force on an object is equal to its mass times its acceleration. So forces cause acceleration in the direction of the force. That's basically the second one, and that's why it's called the law of acceleration. It's F equals ma, and you're going to be using that equation eventually. The last one is the law of interaction. The law of interaction says that for every action, there's an equal and opposite reaction. You've probably heard of that before, but it happens all the time in real life. If you shoot a paintball gun, the paintball goes in one direction and the gun goes in the other direction. That's what it's talking about. There's an action and a reaction. You walking on the floor, you're pushing on the floor with your weight and the floor is pushing back on you, propelling you forward. For every action, there's an equal and opposite reaction. That's basically it. We're just going to be talking about forces and what causes these changes in motion. So you're going to do a worksheet. It's a coloring sheet. You don't have to color it, but it's a maze. And you're going to start at a tree, and I think it's the first law of motion. And then you're going to find the scenario that goes with that first law of motion, and you're going to go in that direction until you get to Isaac Newton's picture. So using those 3 definitions, there's also on the PowerPoint, you're going to be finishing that up. Hope that helped.